Hello everyone, let's continue number 6. So a 423 ml sample of dry oxygen at STP is transferred to a container over water at 22 degrees Celsius and 738 millimeters mercury. What is the new volume of the oxygen? So this problem what they call Dalton's law of partial pressure and combined gas law. So this is number 6. So the volume 1 here has a 423 ml. So we put volume 1 here. Volume 1 is 423 ml. And the pressure 1, which is at STP, so is 101.325 kilopascal. So, and temperature 1, standard temperature, so T. So we have to put 273 Kelvin. And the temperature 2, there's a temperature 2 here, which is 22 degrees Celsius. So it's 22 degrees Celsius plus 273 Kelvin is equals to 295 Kelvin. And we have pressure 2 here. Pressure 2, which is 738 millimeters mercury. So pressure 2, this is 738 millimeters mercury. So we need to convert millimeters mercury to Pascal. So from 760 millimeters mercury divided by then times 1 atm times divided by 1 atm times 101.325 kilopascal. So cancel out millimeters mercury and atm. So the pressure 2 is equals to 738 divided by 760 times 101.325 kilopascal is equals 98.39 kilopascal. At what temperature? 22 degrees Celsius. Okay. At 22 degrees Celsius. So let's find out. So P2 is equals to PO2 equals to PATM minus P water vapor at 22 degrees Celsius. Okay, so P2 is equals to how much PATM again? So it's 98.39 kilopascal. So minus the water vapor at 22 degrees Celsius. So it's 2 here. 22 from 22 degrees Celsius, which is 2.6 kilopascal. So 2.6 kilopascal. Okay. And we need to minus that. So 98.39 minus 2.6, which is 95.79 kilopascal. 95.79 kilopascal. There is our pressure 2 again. And lastly, we need to use now the combined gas law. So in solution here is a solution. So P1 times B1 over T1 equals to P2 B2 over T1. So we need to find the volume 2 again. The volume 2. So cross multiply again. So P1 times B1 times, oh, it's a T2, right? Sorry. Times T2 is equals to P2 B2 times T1. So we need to divide both sides by P2 and T1. P2 and T1. So cancel out here. So equals to B2, P1 times B1 times T2 divide P2 times T1. So here in volume 2 is equals to, what is the pressure 1 here? You need to plug in. The pressure 1 is 101.325 kilopascal. So 101.325 kilopascal times the volume 1, which is, the volume 1 is 423 ml here. So 423 ml times the temperature 2 here. Temperature 2 is 295 Kelvin. So it's equals 295 Kelvin. 295 Kelvin over the pressure 2 again. The pressure 2. So the pressure 2 here is 95.79 kilopascal. So it's 95.79 kilopascal times the temperature 1 here. The temperature 1, which is 273 Kelvin. So 273 Kelvin. So volume 2 is equals to 101.325 times 423 times 295 divided by 95.79 times 273 is equals to 483.49 ml of oxygen gas. So this is your final answer. Alright, let's continue in problem number 7.